Let's get started with compiler design. So what is compiler? Compiler is a program which converts high-level language source code to machine code. What do you mean by a high-level language? You would have encountered various programming languages like Python, Ruby, JavaScript, C++, and Java. These languages are known as high-level languages. Computer cannot understand these high-level languages since they are written in English and they have various operators and various variables, constants, and procedure names. In order to make your computer understand this language, you need a compiler which can convert this high-level language into machine code. Computer can only understand machine language, which could be binary or assembly. So what a compiler is? Compiler is a program which converts these high-level languages into machine code. How a compiler converts high-level language into machine code? So compiler importantly does three functions. The first function is lexical analysis, second function is syntax analysis, and third function is code generation. Each of these functions has various substages involved. Lexical analysis has a lexical analyzer which will perform various things for you. Syntax analysis has a syntax analyzer which will do various things for you. And as far as code generation is concerned, there is a code generator who's going to generate intermediate code into machine code. Now let's see what all stages are available within each of these compiler functions. If you see lexical analysis, in lexical analysis, there is a lexical analyzer. This lexical analyzer is going to read the high-level source code from left to right, and it is going to convert each keyword into a number. This number is known as a token. Each number is unique with respect to the keyword. So tokens will be generated using lexical analysis process, wherein your source codes will be converted to the set of tokens, where token is a unique number generated for each keyword. Followed by the second step is to create a symbol table. In a source code, you may be having variable names, constant names, and procedure names. These identifiers will be stored onto a symbol table. Once these two processes are done by lexical analyzer, then the source code will be sent to syntax analyzer. You will be performing syntax analysis using syntax analyzer. Syntax analyzer performs two steps. The first one is parsing and the second one is semantic analysis. What do you mean by parsing? Parsing is a process where the syntax analyzer checks whether the high-level language source code follows the rule specified by the language. So parser, what it will do, it will quickly read your high-level source code and it will compare whether this follows the language rules or not. How these language rules are defined, we are going to practically show you in the upcoming videos. Once parsing is done, the source code is sent to semantic analysis. What is semantic analysis? In semantic analysis, the syntax analyzer will check whether whatever expression is written in high-level source code, is it meaningful for the machine? If it is meaningful for the machine, then an intermediate code is generated and it is sent to the next phase, or we also call it as a pass. So we send it to the next pass known as code generation pass. In code generation, there are two steps. The first is to optimize the source code, which is your intermediate source code, with respect to time and storage. And second step is to convert the intermediate optimized code into a machine code or else the assembly code. So in code optimization, you're going to make intermediate code time and memory efficient. And in machine code generation, you're going to convert optimized code into binary machine code or assembly code. So if we quickly revise all the three steps, you can quickly see lexical analysis, what it does. You have a high-level program available. You have given the high-level program to lexical analyzer. Lexical analyzer has read the program from left to right and it has created tokens for each keyword identified in the program. From these, identifiers have been identified and the identifiers are now stored into the symbol table. Now this has been sent to Syntax Analyzer, wherein Syntax Analyzer has quickly checked these set of tokens whether they follow the set of rules provided by the language. If the program is syntactically correct, then the high-level program is sent to semantic analysis. In semantic analysis, it is checked whether the expression or the set of tokens does have a meaningful value for the machine. If it is, then the intermediate code is transmitted to the next pass, and that is code generation pass, wherein we will first check, is there a scope of time or memory optimization? If yes, we do optimize that code. And finally, this optimized code is converted into a machine code. If you have to write this in your examination, generally students can design these phases using this diagram. So let's say you have a high-level source program written in any of the leading programming languages like C, C++, Java, Python, or any of the other languages. Now what Lexical Analyzer will do? It will take the program, it will read it from left to right, and it will it will convert each of these keywords into numbers. Now these numbers will be identified, the identifiers will be identified, and those identifiers like constants, variables, and procedure names will be stored onto a symbol table. Now once this is done, then we'll go to the syntax analysis phase. In syntax analysis, the syntax analyzer is going to read the set of tokens from the symbol table, and he will quickly identify whether the rules are being followed by these set of tokens or not. If the program is syntactically correct, then we'll send the program to semantic analyzer. Now in semantic analysis, we are going to compute if the set of tokens does have a meaningful value for the machine or not. If yes, we'll give it to the next pass, which is intermediate code generation. If semantic analysis has any kind of error, then we'll give that error, we'll raise the error, or we'll raise the warning with respect to error handler. Now intermediate code generator will now go through the next pass, wherein code optimization with respect to time and memory will be done, and followed by the final machine level code will be generated in assembly or binary language, and then the target program, which is the .obj file or the object codes, will be generated. So now I hope you understand what is a compiler. Compiler is a program which converts high-level language into machine code, and to do that it performs three important functions. The functions are lexical analysis, syntax analysis, and code generation. In syntax analysis, we create tokens and we create a symbol table. Then in syntax analysis, we do parsing and semantic analysis. In code generation, we do code optimization and machine code generation. And finally, our high-level language is converted into machine code. Thank you so much for watching.